Well, good morning, good afternoon, good evening. Welcome to our Innovations in Tobacco Control seminar series. My name is Joanna Cohn, and I am Director of the Institute for Global Tobacco Control at the Johns Hopkins Bloomberg School of Public Health. And I am absolutely delighted to introduce today's Innovations in Tobacco Control speaker, Dr. Anna Rule. So Anna is an associate professor in the Department of Environmental Health and Engineering and director of the Environmental Exposure Assessment Labs here at Johns Hopkins Bloomberg School of Public Health. Anna did a bachelor's degree in biomedical engineering in Mexico City and then came to Johns Hopkins and completed a master's degree in industrial hygiene and environmental sciences, a PhD in environmental health sciences, and a postdoc in environmental health and aerosol sciences. So she has been at Johns Hopkins for almost 30 years. Dr. Rule has established a research program that integrates advanced laboratory methods for the assessment of exposures in a multitude of matrices, including air, water, soil, as well as human and animal biospecimens. She is an expert in exposure to airborne environmental hazards with 20 years of experience in research related to exposure assessment. Her lab developed an innovative method to collect e-cigarette aerosol that allows us to measure chemicals in the aerosol, including nicotine and metals. And they were one of the first to establish that e-cigarettes are an important source of metal exposure. Now, last year, Dr. Anna Rule was recognized with the Johns Hopkins Discovery Award, along with Dr. Michel Vaz, which supports innovative collaborative research with cross-disciplinary teams. And in 2023, she was named a Johns Hopkins Moonshot Cancer Scholar. And quite a few years ago, she also received a Fulbright Scholarship, but that was a few decades ago. So I am absolutely thrilled to have Dr. Anna Rule here to talk about her research regarding e-cigarettes and metals. So over to you, Anna. Thanks so much for being here.
Thank you for the invitation. I'm here to talk about the work that we have been doing for 10 years, a little more, for investigating electronic cigarette toxicity with a specific focus on metals. So I am going to talk, I know here in the audience, there are probably experts that know way more than I do about electronic cigarettes. But I still think I'm going to give a brief overview of what they are, the huge changes that we have seen over time, and the role that the FDA has had on all of these changes. Chemicals found in electronic cigarette aerosols in general, but I'm going to be focusing on metals for the rest of my talk. And I'm going to talk a little bit about a study we did related indoor air quality study in a vaping convention, and then talk about our NIH-funded EMIT study and some of the results we had from all of these studies, and jump into some conclusions. So I know this is a super, crazy slide, but when we first saw electronic cigarettes, they looked like cigarettes. They even were called cigalikes. They were introduced into the market around 2004, and they had like a component called the cartomizer that contained the liquid and a metallic coil that heated the liquid to generate the aerosol, and a battery to provide the power. That has stayed consistent throughout the time. All of these completely different forms and shapes and new things that we see every day still contain that battery, that tank with the liquid, and the metallic element that heats the liquid to generate the aerosol. Some things I want to point out here on this slide. Initially, those cigalikes, we called them closed systems. You could not modify them in any way. Then appeared around 2010 pens that contained this tank that you could actually, for the first time, refill and change the liquid, the flavor, the percent nicotine. You started to get some customization with these. And around the same time, they started to get bigger and it became a little bit of a cult to have your own device, and so very customizable. We call them mods because they are very modifiable. And then right around 2015, the market started to see these completely different things. They completely changed the feel and the shape. They looked like USB drives. The manufacturers changed the chemistry of the liquid, which meant they could pack more nicotine per milliliter of liquid, so increase the concentration of nicotine. And of course, they started marketing to mostly young, never smokers. All of the previous devices up to the mods, they were mostly marketed to smokers to quit smoking or to change from smoking. And once these pod devices came into the market, there has been a really rapid change. Every couple of years, there's a new thing on the market. They are now the most common ones are disposable, completely disposable. You just recharge them because some of them can give you up to 7,000 pods, so you need to constantly charge them. And the new things that I just recently learned that came into the market are called smart vapes. So I'm calling these the sixth generation because, again, they're completely changing the way people are going to use these devices. They include a phone, so you can, within your same vape, within your same electronic cigarette device, you can talk to your friends, you can play games, you have AI capabilities. So it's, to me, a little scary because it now has the addiction of the phone, which we're all addicted to the phone, and the addiction of the nicotine. So again, I think mostly targeting young populations. So the role that the FDA has been playing has been really interesting, in my opinion, because all the way in 2014, they established this deeming rule. They proposed a deeming rule that would regulate electronic cigarettes the same way as they regulate tobacco. And so the deeming rule went into effect. It was advertised for 2 years so that everybody was prepared. The deeming rule went into effect in 2016. And right around that time is when the Juul devices, these pod devices that completely changed the game, came into the market. They contain this high concentration nicotine and many very popular flavors, and they started to be marketed primarily to youth with their flavors and the colors and the way the marketing was played out in the media. Then the FDA actually put a partial ban on certain flavors, the most popular flavors actually, and so that really affected the market. For a while, we were recruiting at that time. People were just not vaping these devices because they couldn't find their preferred mango or creme brulee flavors. So only menthol and tobacco flavors stayed on the market. And then around that time, these new devices came into the market that were the puff bars that did not have a pod. So they got a way around that rule because they said there's no pod in here. So the whole device was disposable, not just the pod. And many flavors. Even the packages that they come in look like a candy. So a little concerning in that respect. So FDA issued warnings to puff bars to take the product off the market, but puff bar came back with a reply saying this is synthetic nicotine that's in here. It's not tobacco product, so you can't regulate us. So around that time, also, unfortunately, in my opinion, FDA coincided all of the things that FDA had been working for to authorize some devices to kind of like regulate a little bit, coincided that the FDA actually authorized the first e-cigarette. And so even though the regulation is very specific and it only authorizes one type of device with one type of flavor, this Vuse device that has tobacco flavor, unfortunately, the market or the public saw it as, oh my God, this is fine. It's authorized by the FDA. Like no, there's no nuance in that type of perception. And then FDA finally was able to regulate synthetic nicotine as tobacco products, and started issuing warning letters to some of the manufacturers and civil penalties. But consistently, it just kind of like seems that they're behind the game. The market is running away, and research is playing catch up to the fast market changes. There's mounting evidence from our lab and many labs around the country and the world that potential long-term effects of electronic cigarette use. And unfortunately, the slow regulatory process with very little funding for enforcement is not helping. Some of the things that keep these very popular devices are these fruity and ice flavors, so minty flavors that make that throat hit easy on the throat. And so this is just a little example of the flavors. Like I was saying, they come in different shapes and forms and devices, and they keep evolving. And they have now, the last one that I saw, up to 50,000 puffs. So this is, in my opinion, very concerning. I'll talk a little bit about it later, but these ice flavors use this non-menthol chemical called WS-23 that produces the cooling effect. It has been studied a little bit in the past couple of years and has been shown to induce oxidative stress, increase reactive oxygen species generation in the lung epithelial cells. So it's probably not a safe compound to be putting into your lungs. There's no established inhalation safety threshold. It's such a new compound, and it raises concern about the potential health effects just because of this compound. And to be fair to the FDA, they keep trying to crack down. In 2024, June, they unveiled new task force aimed at cracking down on illicit e-cigarettes. Just last month, they seized 86.5 million worth of illegal e-cigarettes in the largest ever operation, but we still see them all over the place. So changing gears a little bit to the more chemical area of my talk, the chemicals of concern that have been found in all electronic cigarettes are, of course, nicotine. It's like the main reason these devices exist is to deliver nicotine to the user, which we know is an addictive substance with cardiovascular and neurotoxic effects, especially for younger adults. We have found aldehydes and carbonyls, which are provoke airway constriction, and they damage the airway cell lining of the lungs. There's polycyclic aromatic hydrocarbons of PAHs, which are carcinogenic, and they have reproductive, kidney, and liver damage effects. And some investigators have found endotoxins and beta-glucans in the aerosol and the devices, which cause asthma exacerbation. And a couple of years ago, our lab with one of my postdocs, Mina Terani, did a non-targeted analysis of the aerosol that is produced by some of the electronic cigarettes, and they found close to 2,000 chemicals. Some of them had never been found before. It's more like because we haven't looked for them, we haven't found them. But it seems like there's no end to the type of chemicals that you can find in the aerosols. And of course, metals, which is the focus of my talk, which some of them are carcinogenic, many of them are neurotoxic, and some of them are cardiotoxic. So they're definitely toxic to the human, especially by inhalation. And so the reason we focus on metals is because the liquid that is heated up to produce the aerosol is in contact with a metal heating element in every single case. There's no possibility to heat up that liquid and produce the aerosol unless it's in contact with a metal that it heats up the liquid to generate the aerosol. And some of the most common heating elements include nichrome, which is an alloy of nickel and chromium. Canthal is another alloy that is very commonly used, which is iron, chromium, and aluminum. Stainless steel was used for a while in the modifiable devices, which is an iron, chromium, nickel, manganese alloy. And of course, all of those alloys usually also have other contaminants in them. And then even ceramic coils, which many people have been claiming for some time, well, what about ceramic? We just use ceramic and then we get rid of the metals. But the ceramic coils also need some kind of metal or metallic element to heat them up because the ceramic is not conductive. Anyway, we know that nickel and chromium are inhalation carcinogens, and so we were concerned that so many of these alloys contain those metals. That's the main reason we started doing this work. So back in 2015, we started recruiting participants to collect their devices. And we recruited at that time, we had very modest funding. So we recruited 50 users. All of them were mod users because that's what was on the market. And then in 2017, we got a little more funding. So we recruited 50 vapors and 50 non-vapor controls. And then wave 3 with NIH funding, we recruited some pod and mod devices, some dual users, because we were always interested in seeing the dual effect of smoking and vaping, and some smokers and 30 controls. And so wave 4 and wave 5 are ongoing. We keep recruiting participants. We have 53 vapors and started recruiting some disposable users of disposable devices, 36 non-vapors. And this is through Dr. Herrera, that used to be my postdoc. She's now at Penn University, and she has a K99 with continuing this study. So for the study, we collected from each participant their dispenser fluid, the liquid that comes from the little dispenser to fill your at that time modifiable devices. Then we also collected what was left in the tank after vaping it for a while, and then some aerosol. Every participant sits down with us for about an hour and answers an extensive questionnaire so that we can capture their behaviors and other potential metal sources of exposure that they have. And we also collect urine, saliva, exhaled breath condensate, and blood. In this, especially, we started collecting blood in the third wave. And we analyze all of it using inductively coupled plasma mass spectrometry, or ICP-MS, for a suite of metals. So when we started recruiting, we went to these vaping convention. Somebody was aware, why don't we go there and see what people are using, and maybe we can recruit some participants. And what we didn't realize is that people were actually going to be vaping in there. And they have these like trick competitions that they call, where you do like crazy forms with your vape. And then at some point towards the middle of the afternoon, the person that was on with a microphone saying, close doors and windows. And once the doors and windows were closed for maximum effect, everybody puff. And so a couple of the people, of my students, had to actually get out of there because they were feeling sick. It was very intense. And one of the craziest things is on the door, there was this sign: no smoking, including e-cigarettes and other smoking devices. But I guess that was excluded for the vaping convention. So after this experience, we decided, and we wrote it down in a paper commentary, we decided to go in and actually measure what was in that air in the convention. So we brought in some air sampling equipment inside a backpack, and we measured for PM10 using real-time and filter devices. We measured airborne nicotine, and we measured total volatile organic compounds, carbon monoxide, nitrogen dioxide, and carbon dioxide using this real-time instrument that we had in the lab. So we went to 3 teams to cover the 8 hours of the convention. And it's all reported in a paper, Assessment of Indoor Air Quality in Electronic Vaping Convention. So here, I'm going to just quickly walk you through it, but on here, we have the concentrations of particulate matter. PM10 is in red, and carbon dioxide is in black. So you can see the minute by minute changes, and the volatile organic compounds are in green. These vertical times are when we went out of the venue to exchange the backpack, so that the new team of 2 people came in with the backpack. So you can see that the instruments are responding to the outdoor air, and then when you come back in, they go up in concentration. And the concentrations of the particulate matter, PM10, you can see up to 20,000, 15,000 micrograms per cubic meter. That is pretty intense. I mean, you saw in that photo, that is a lot of particulate matter in the air, even if it's vaping particulate matter. It's, I'll show you a photo in a couple of slides. So anyway, now the other thing that you can notice maybe is halfway through the afternoon, the particulate matter monitor, real-time monitor, just completely stopped working. It got clogged. It was so much junk that went in there. So, so we found PM10. We had 2 filters, so we averaged them. Like I was saying, 8,000 micrograms per cubic meter is a crazy amount of particulate matter. It's several times higher than, orders of magnitude higher than the EPA National Ambient Air Quality Standards. And nicotine at 124 micrograms per cubic meter is higher than some concentrations that we found years ago in bars and nightclubs. That was 24. So clearly nicotine is in the air also. So this is a photo of the filter that was collected. Like you can see this like goopy, sorry for the technical term, goopy substance that is going directly into the lungs. And this is secondhand. Remember, this is from the air. So this is not just the vapor that is inhaling this. This is when you're inside one of these conventions. So these are some of the liquids we collected from the devices. You can see here, it's so before they are vaped. So I think if vapors saw these, they probably would think twice about putting this into their lungs. Because when you buy it in these little cartridges, it looks more harmless. And so Joanna mentioned at the beginning, we devised a simple device to collect electronic cigarette aerosol. It's relatively easy to use, although it took our postdoc quite a couple of months of trial and error to figuring it out, but it re-aggregates the aerosol. First, the electronic cigarette is vaped, and that aerosol is re-aggregated into liquid and passed through a series of tips to become again a liquid, which is very convenient, especially for metals and nicotine analysis. So the first 56 devices that we collected, like I said, we were expecting chromium and nickel, but our ICP-MS instrument gives us a suite of elements all at the same time. So we decided to run a whole panel. And one of the things I want to point out is that this column is what we found in the dispenser before it goes in contact with the tank. So even from the plastic dispenser, already 46% of the devices contained the chromium and 55% contained nickel. That percent went up in the aerosol and 100% in the tank. But of course, nobody really is exposed to what's in the tanks. But we wanted to see what was the device. But we were not expecting to find, for example, arsenic and lead. We don't know why arsenic and lead are, especially in the dispensers. So the thing is, I think it's quality control that somehow during the production, these metals are just being introduced into the dispensers. Then we actually put this into a concentration, so micrograms of metal per kilogram of element, and you can see here the dispenser concentrations were lower in general. The concentration of metals in the aerosol are higher than in the dispenser and the highest in the tank. So these to us meant pretty clearly that the metals, at least these metals, are coming from the contact of the liquid with the metallic coil. And you can see some of the metals of concern, of course, nickel, manganese, chromium, and even zinc, which is an essential element, but you don't want to put extra zinc on your lungs. We had a little bit of a lull during COVID. We could not recruit participants, but we went out and bought some of the devices from the stores and on the internet and set out to keep analyzing them in our lab. And so here I'm giving you concentrations in milligrams per cubic meter of air, and the mod devices, these big tank devices, are in red. The pod devices are in blue, and the disposable devices in yellow. And even though most of them, just at first sight, most of them, you can see mod devices are the highest concentrations, we found this a little concerning, that for cobalt, which is also a pretty toxic element, especially to the lungs, the highest concentrations we actually found in the pods and the disposable devices, same as zinc. And there was really no difference in nickel concentrations between the three types of devices. When we looked at the data by flavor, here we have by tobacco flavors are in red, the mint menthol flavors are in blue, the mango flavors or more fruity flavors are in yellow, and other flavors, which is only 5, we put in green. So one of the concerning things is you can see just visually the highest bars are the red ones, which are the tobacco flavors, which are the flavors that the FDA has been authorizing. So just to keep that in mind, not just, I think we need to be careful about what is authorized to go in the market. Then one of my postdocs also did some digging into those devices where she found higher arsenic, because arsenic, same as chromium, it depends on the valence state. The toxicity is not equal across all of the metals. And so inorganic arsenic is especially toxic, especially arsenic 3 is more toxic than organic arsenic or arsenic 5. So some things to just point out quickly on this slide. Some of the devices, these disposable pod devices, she found some of the highest concentrations, especially on the market at that time were these STIG brand. So she further analyzed these to speciate between arsenic 5 and 3, and she found that the minty flavors, actually both flavors, but especially the mint, had the highest concentration of arsenic 3. So with levels similar or very close to the California EPA chronic inhalation reference exposure dose, which is 0.015, right? So she found between 0.017 and 1.8, and the reference dose is 0.015. So significantly higher levels, especially of the more toxic arsenic 3. So I think we need to do some more digging into that. Then changing gears again a little bit, we also started looking at the the rich information we had from the questionnaires. And look, we have 2 papers already out in which we describe the use behaviors from the participants and some of the ways that they use their device characteristics and how that impacts their metal exposure. So we were one of the first studies to report the association of electronic cigarette use with metals in urine, saliva, and exhaled breath condensate. It was only 59 participants, so we didn't really have a strong signal. We had some indication that maybe there was a trend on as the highest aerosol metals, you had the highest increased metals in some of the biospecimens. But since then, we now have been curating better the rest of our data. And a student right now that just graduated in May, he's been helping us with this big data set to work on the paper for the results on urine with more. Now we have 209 participants. 29 of them are pod users, which you see in these little orange boxes. 114 are mod users, and 74 controls or non-users. And so you can see that there's a signal there for sure. There's a huge spread. The variability is very large. It's really hard to tease out all the sources of exposure in these participants, but it definitely looks like there's a signal there for the pod users seem to have higher concentrations of chromium, manganese, nickel, and even lead, especially compared to the controls. That's for the metals in the urine. And another one of our students, now Dr. Anna Tillery, is a postdoctoral scholar at Columbia University. She's been analyzing these data for blood metals. And when she stratifies by device type, we see there's a signal for chromium and nickel, not on every devices, not every time, but there seems to be something. We're still working on the data. This paper is in preparation, and we hope to have it out soon. And when she looks at the metals by the user behavior, we see there's these by flavor category, there's a signal for nickel. So people that vape the fruity or candy flavors have higher odds of having higher nickel. And the same for those who vape more liquid per week. And that's also for zinc. Then finally, I'm going to just tell you a little bit about this other thing that we've been doing. The metal toxicity is not equal across metals. Not all metals are equally toxic across all forms. And so we know that there's, metals can be found in particles or in ionic form, so like dissolve in the solution. And the way that they behave with cells dictates the toxicity. So metal ions require transport to cross the plasma membrane, and particles are taken up through cytosis. And so whether the metal is present as a solid particle or as an ion can affect the bioavailability in the lungs. So we've been looking a little bit into that. And with our other doctoral student, Dr. Sarah Lamb, who is now a postdoctoral fellow in Albany, she's looked at these devices, and actually this is just total metal concentration by number of particles. So she looked at these brands, Elf Bar and Orion, that were very popular a couple of years ago, and Views, which is actually the device that was approved by the FDA. So you see the Views as this open circle-ish. And for chromium, the Views devices have higher or as high as these other ones. The Orion cool mint was the lowest. For nickel, again, so the chromium and nickel signal are still there in these newer devices, and there's definitely particles also, as well as in ionic forms. So just looking at it in a different way, there's a size distribution, which is around 100 nanometers, very inhalable, goes deep into the lungs for both nickel and chromium. Although you can see that the number of particles are by each dot, so you can tell there's fewer chromium, for example, in these Vuse golden tobacco than in the Elf Bar gummy, because you cannot distinguish between the dots. So there's just a higher number of particles, but all of the devices produce similar range of particle sizes. And then finally, we took a look at the ceramic coils. I was telling you how some have argued that using ceramic coils would get rid of the metals. So we wanted to investigate these, especially because we know ceramic coils either have a metal element inside or are surrounded by a metal element. So there's some metals involved. And so it's actually true that somehow the ceramic seems to work as a filter of some sort, because the ceramic coil, which is in circles in this graph, tend to be the lowest concentrations of all the ones that we found. So you can see the metals from the ceramic coils are the lowest across, except for tungsten, which is probably the heating element of that device. There are still metals, but considerably lower concentrations. So this is probably a good news. So in conclusion, we found heavy metals detected in all aerosols that we have tested. Cadmium has been the lowest of the metals that we have found. And the reason we were focusing on cadmium is because it's a known metal, toxic metal present in cigarettes. So we were especially concerned about cadmium. There's wide variability within and between types of devices, as you saw, these huge error bars, brands and flavors. Higher power tends to produce higher concentration, but not necessarily. It depends on the physical way that the devices are made. The concentrations of most of the metals are highest on the mod devices, except for nickel, where all of the devices had the same concentrations, and cobalt, zinc were higher in the pod devices. Concentrations of most metals in pod devices were higher in tobacco flavor. So this is concerning because the tobacco flavor is the one authorized by FDA. Also concerning is that we have found arsenic to be potential concern on disposable devices, or we at least need to look a little more into the newer devices that are on the market to see, at least rule out that there's no concern. For the arsenic, chromium was found mostly as ions, and nickel was found mostly as particles. And this single particle ICP-MS is a promising way to determine potential cell uptake and some mechanisms of toxicity for toxicological studies. This is our students photographing the array of devices that have come. The participants come and leave their devices now with us. And so they're preparing a paper on that. And here, just to wrap up, it's been argued that this is a harm reduction strategy. And so I borrowed this slide actually from Dr. Jonathan Samet. When I first saw it, I think it just captures exactly what we're dealing with here. Yes, there are some pros. There's potential health gain from smokers who quit. We know there's very few things more harmful than cigarette smoke. There's potential health gains for smokers who substantially reduce smoking by use of electronic cigarettes. And there's potential health gain for reluctant smokers who switch to electronic cigarettes. Potential because we don't know for sure. I don't think we have the whole picture of what electronic cigarette health effects. unfortunately, I think the cons outweigh the pros, because now we have renormalized this smoking or the behavior of bringing something to your mouth in society, which for 30, 40 years, the public health community had done an outstanding job of making smoking not cool. And so now that has been reversed, unfortunately. There's increased risk for smokers who switch to electronic cigarette instead of stopping smoking. So now you're still exposed, you're still inhaling these substances instead of just air through your lungs. There's the increased risk of smokers who become dual users, which now you're exposed to both at the same time. There's also increased risk for ex-smokers who now started using electronic cigarettes instead of staying with their lungs free of chemicals. And then, of course, there's the way increased risk for never smokers, for young kids that were just breathing air and now are bringing all these substances into their lungs by use of electronic cigarette. So I think this is a cautionary tale, and I just want to end up with that and acknowledge all my sources of funding. Of course, none of this can be done without funding. There's a huge amount of work that goes in there. We've been fortunate to have all sorts of funding, and the University of Graz actually helped us develop the method and analyze some of the particles. Of course, thank you to our participants and to a huge team, because I could not have done any of that I presented without these talented people that are always bringing joy and knowledge and important and interesting things into our labs. So thank you very much.
Wonderful. Thank you so much for taking us through all of that work, your team's work and research, and how it, looking at the exposures, again, in different ways to try and triangulate. So we have a lot of questions. So I think thank you for leaving time for some questions. I'm going to jump in, and I guess one place to start is, I think, combining a couple questions, just asking about whether these metals, or some of the metals, you addressed it a little bit, but maybe if you could say a little bit more, if they're also found in cigarettes, and again, if you could talk a little bit more about differences between cigarettes and e-cigarettes in terms of metals, I guess similarities and differences.
Yes, of course, and we know there's metals in cigarette smoke. There's especially high for cadmium, chromium, lead. Those are important sources of metal exposure in the general population. Smoking is. So the levels that we have found for some of these metals are comparable to those of cigarette smoke, except we found higher levels of nickel and zinc in electronic cigarettes than what has been reported for cigarette smoke, and lower for cadmium, like I mentioned a little bit. We work on especially looking for cadmium. And so some of these exposures are similar. I know some people claim that electronic cigarettes lower the exposure for many chemicals. That might be true for other chemicals, but it's not true for metals. That it's very comparable.
Great. And so you've talked about the exposure, we think that part of the exposure from e-cigarettes to these metals are from the metal coils and metal elements in the e-cigarettes. And I guess, so how do cigarettes get the metals?
Oh, right. Which is how some of those dispensers, I think, also got their metals. So the tobacco leaf is a very good uptaker from metals from the soil. So these are metals that are naturally occurring in the soil, and most of the plants require these metals for normal functions. So do we. Chromium-3 is an essential metal. Manganese is an essential metal. Zinc is an essential metal. So our bodies require these metals for essential functions. But there's a point where they become toxic when you exceed certain levels. So the tobacco leaf uptakes metals, And we think that's one of the ways in which some of the electronic liquids get the metals, and we know that's how tobacco cigarettes get their metals.
Thank you. You made it very clear. Thanks so much. So this is a bit of a leap, and this is not, the research that you presented to us today, but there's a question of, you talked about presence, exposures, levels of these metals that you found. And I guess one of the questions is about the levels of the metals that you'd be concerned about in terms of health impact. And I guess, you showed us some of the sort of levels that, that we aren't supposed to exceed, but maybe you could talk a bit more about that. And then also building on that, like, what are the actual health effects you might expect to see based on those exposures?
Right. So nickel and chromium actually have EPA, and lead have EPA minimum risk levels established. And we compared in one of our first papers, we actually converted the units that we come from the instrument, the micrograms per kilogram of metal, to micrograms per cubic meter of air, which is what is regulated for inhalation toxicology. And about half of our devices exceeded the safe limit, the limit that EPA has established for a risk level of 1 in 10,000, I think, is what it is. I would need to check, but about half of the devices exceeded for manganese, for nickel, and for chromium. Now, chromium, like I mentioned before, is tricky because we did not speciate between hexavalent and trivalent, so this is just the total chromium. And the same for the EPA ambient air quality standards for lead, which we know there's that safe limit, and half of our devices exceeded that limit. So you're not breathing electronic cigarette aerosol continuously throughout the day, but we believe that, especially as these devices become more and more I guess, stealthy and easy to use and to have in your hands, like I was mentioning before with these smart vapes, that now kids are going to be, or people are going to be having them using their phones and vaping. When you ask vapors, when we ask vapors in our questionnaire, how often do you vape? Some of them can't even think about the answer. It's like they have to do a calculation, maybe every second, every couple of seconds. Some people have the vapes with them all the time. So it's hard to tell exactly how much, but we think it is enough that it's concerning, that the levels are at a level where even though you're not breathing it during the night, for example, or times that you're not vaping, they are reaching levels that are concerning. These are chemicals that you should not be putting into your lungs, period.
Great. And the second part of the question, are there specific health effects we might expect to see from exposure to the metals that you're finding?
So yes, so there's some, especially for people that are sensitive. The human body is really amazing at the capacity of regeneration, and sometimes I think we abuse that. So the lungs have all of these mechanisms of repair, but one of the reasons we started looking for cobalt in particular is because we got a case study. It's a patient that ended up in the emergency room with this bronchiolitis, this inflammation of the lung. And the doctor that was seeing that patient had been trained in occupational medicine, and he had seen these in occupational settings for people exposed to cobalt. So they asked us to please look for cobalt, and we found it. And so we started looking for this and found it. So cobalt in particular is very, very, has known to have these inflammation effects. So does nickel, and nickel is also a highly people that have allergies to nickel, like women that wear earrings may know some just are very allergenic. And so some people have been having allergic reactions to the nickel inflammation. And right before COVID, I don't know if people here remember, but we had that EVALI outbreak. And even though it was decided that it was not the electronic cigarettes, it was not the metals, it was these other substances. I think the metals contribute to the inflammation and the exacerbation of symptoms.
Great, thank you. And I guess on the topic of inflammation, there's a question about if you've looked at some of the biomarkers for inflammation in the blood samples and
We've
tried to
just looked,
correlate that
we
with.
just started looking at that. So I don't have any results on that. We have been looking into it, and yes, there's some markers of inflammation, and hopefully we'll have a paper soon.
Great. And then I guess in terms of policy implications, I don't want to push you to a place where you don't want to go because of course, there's lots of data inputs into decisions about what to do. And as you've said, metals are one exposure. There are other types of exposures and impacts. But I guess one of the questions is about, your findings around tobacco flavor, and that you found some higher exposures or for tobacco flavor compared to other flavors. So I guess like at this point, I mean, do you feel comfortable? Is there sufficient evidence to recommend how we should be thinking about flavors around e-cigarettes?
I think, I mean, at least the last time I checked, the FDA requirements or the list of things that they check before that approval mechanism, which is very lengthy. I'm not saying no, it's very lengthy that what manufacturers of e-cigarettes need to prove to get an e-cigarette approved by the FDA. It's a really lengthy, but metals in the aerosol is not one thing that is considered, at least not as far as the last time I checked. So I would like for the FDA to at least incorporate that as part of their decision mechanism, and try to regulate a little bit of what is in the liquids, and even better if they can test the aerosols before they make a determination.
Great. Well, we have like some other questions, but I think we're going to end it there. But I really appreciate you sort of taking us through again these multiple methods, like the multiple ways that you're looking at this. And using different types of exposure, looking at the different components of the process of using e-cigarettes. So, I don't know if maybe as a last point, you've talked a little bit about this, but anything you want to share about upcoming work and things, big questions that you think are still need to be answered?
So, I mean, one of the things that I have been saying from the very beginning when we started this work is I don't want to wait 10, 20, 30 years down the line to realize that all these people are coming up with cancers or other chronic diseases like COPD, like we found with cigarette smokers. And so there's new mechanisms, there's new toxicological ways that we are now being able to detect these early markers of cancer causing. So we're looking into that, trying to establish how all of these inflammatory processes actually predispose to this cancer, potential cancer causing endpoints, which I think is like nobody wants to get there. And so especially if these devices were introduced into the market as a risk reduction strategy, like you were saying.
Great. Well, again, thank you so much, Dr. Anarul, for a terrific presentation and for the work that you've been doing over the last decade on this topic. Thanks so much.
Thank you for the invitation. Thanks everybody for joining.